All right, so this is AP Calculus Self-Check 11.5. This is going to be the key. I should label this the key. Today's date is Thursday, March 19th, 3/19, 2020. This is a calculator-enabled self-check. So the first thing we're trying to find is this area R down here, and note that in order to find that area, we have to split it into two different regions. The reason that we have to do that is because the definition of the integral is always going to be the curve, the area between the curve and the x-axis. So we have two different curves that we're going to be talking about. So the first curve is tangent, second curve is 2 minus x to the power of 3. But we need to find what is the x-coordinate of this intersection, because otherwise we can't find the bounds on our integral. So the first step is to find where is this intersecting, where are these two functions intersecting, and what is the x coordinate of this intercept down here. This is obviously happening at 0 because it's a tangent function, so we can skip that. Okay, so to find this intersection, first we pull up our calculator, we plug in both of our equations. Our window, I know this probably messed most of us up, should be between 1 and 1.3. 1.5 will work as well. We definitely know it's going to be between 0 and something, so you should have done 0 and 10 or 0 and 5. 0 and something, don't do negative because it'll definitely mess it up. And then once you do that, you zoom 0 and you get the following graph. If you did my exact window 1.3, so I get this graph. So I want to find that intersection point, so I'm going to do second trace to calculate the intersect. So I hit 5, I hit enter, and I'm going to guess, I don't know, about 1. 1, and I get 0.902. So let's come back in our notes and label this 0.902. And I need this x-intercept right here. So in order to do that, I'm going to go second trace to calculate the 0. So I hit 2, and I need to, which curve am I on? I'm on the wrong curve. So I'm going to hit up or down, I guess. Now I'm on the right curve. You can see if I go left or right, I'm on the correct curve. And the left boundary, I'm going to say, I don't know, 0.5. My right boundary is going to be, let's say, this is, the window makes it really hard, but I'm going to say 1.25. And my guess is 1.2. And we get no sign change. Uh-oh. So I did the wrong bounds. So let me try this again. So I'm going to do a second trace to calculate the 0 again. And oh, I know. Okay, so my left bound, I'm going to do 1. My right bound, 1.29. And my guess is going to be 1.2. Now I should have a sign change. And no, what? It should be happening at 1.26. I don't know what's going on. Let me make my window slightly different. Let's go to window. Let me come to 1.5. I'm going to graph this thing. What is going on here? Oh, did I select the wrong function this last time? Maybe that's what happened. Second trace to calculate the 0. I was on the wrong function, wasn't I? Yep. So I'm going to do left bound there, right bound 1.3, and then 1.2 is my guess. There we go. Now I should get, yes, 1.2, I guess 60 when I'm rounding. 1.260. So I come back here, 1.260. Okay, so now I know the bounds for everything. I'm going to say bound between here and here of my tangent function, and then bounds between here and here for my cubic function. So write it out. I'm going to say this is going to be equal to the integral between 0 and 0.902 of our tangent of x dx function. And then I'm going to add that to the integral between 0.902 and 1.260 of that cubic function, 2 minus x to the power of 3, that thing multiplied by dx. Cool. And then I already did that in my calculator, so if I second quit out of it, that's what I did all there in the same line. You can add these integrals on the same line, and I got 0.729. So 0.729. I know I'm going fast, and we might have made a mistake on this one, but please go back and practice how to enter this on the calculator. You can do it on 2 separate lines if you want, or just 1 line like I did. But there's our answer, 0.729, and box it. Next, I need to find the area of S. S, I don't need to break apart. It's just the top minus the bottom. So I'll say this one is equal to the integral of top minus bottom, integral of top minus bottom. I guess the shortcut for this one was the integral of left plus the integral of the right. So this one is going to be equal to the top function for s is the cubic. So I'm going to say the integral between, we already have the bound 0 and 0.902. The top is that cubic 2 minus x to the power of 3. And then all of that is going to be minusing tangent of x. Okay, and then that whole thing needs to be multiplied by d of x. So we've written our integral correctly. And again, I've done this on the calculator already. So the integral of y2 minus y1, and I got 1.161. So come back here and I say 1.161, final answer, and box it. I know I'm going kind of fast. Are there any questions on A or B up to this point? And if it feels like I'm talking too fast, I know that you guys are probably frantically writing notes, but if you have the ability to click on participants in Zoom, there's a button that says raise hand, and it pops up on my computer like flashing red light, like someone raised their hand, and I can call on you. Silence means continue. Okay, so C, find the volume generated when it's revolved. Every single time I see the word revolve or rotate, that means pi. So my general formula here is going to be a pi integral of, if it's x-axis, it's super easy. If it was something else, it'd be a little bit harder. It's just going to be outer squared minus inner squared. And then more specifically, it's outer minus k squared and then inner minus k squared, but our k is 0 in this case. All right, so what is we actually typing here? We're going to be writing integral from 0 to 0.902, again, 0.902 because it's s. And the outer, so around the x-axis. So I'm rotating around here. The outside function is this function, which is the cubic. So the outside is going to be the cubic function. I'll write down the 2 minus x to the power of 3. That is going to be the quantity squared, because that's the radius squared minus the other radius squared. And I have tangent of x. That is going to be tangent squared of x now. And all of this stuff is going to be d of x. Cool, and I haven't finished typing that because if I finished typing it, it would have kicked my screen off. So I did y2 squared minus y1 squared with respect to x from 0 to 0.902. And I should get about 8.332, yeah. This is equal to 8.332, final answer, and box it. All right, so self-check 11.6. Again, a calculator-enabled self-check. This is going to be our last self-check before we do the pre-test tomorrow on Friday. So very similar questions. Find the area of R. Area of R is going to be equal to the integral of the top minus the bottom. So what is that going to be equal to? It's going to be the integral between something and, we don't know this interval. What is that x-coordinate? We don't know that x-coordinate. Well, I know it's cosine, so I know that this is going to be pi over 2 just because I know how cosine works. It goes pi over 2, then pi, then 3 pi over 2, and then 2 pi. It repeats every 2 pi. But if you don't know that, you can still solve it with your calculator. How do you do this? So pulling up the calculator, if I go to my graph, I'm going to find this intersection. So I go second trace to calculate the intersection 5, and the intersection, enter. I'm going to guess about, I don't know, 0.5. And I get 0.739. So I'm going to come back in here, 0.739. And if you want to find that one, it's going to be pi over 2. If you're going to go here, second trace to calculate the 0 to of not this function, but this function. The left boundary is going to be sure right there. My right boundary is going to be as far as I can go, so about 1.59. I think 1.6 is off my graph. And my guess is 1.5. And I should get a 0 at 1.571. So I can say, or 1.571. All right, so my integral for s is going to be between 0 and 0.739. So 0.739, and my function is going to be top minus bottom. So which one is on the top? The curvy one, the cosine function. So cosine of x minus x. And then all that stuff, my minus sign got mixed up with my x. All that stuff is going to be multiplied by the thickness of each slice, d of x. And I did that on the calculator already. So if I second quit out, I did cosine of x minus x with respect to x from 0 to 0.739. I got 0.400 with correct rounding. So 0.400, final answer, and box it. Part B, find the area of S. Okay, S is going to be divided into 2 regions. It's going to be the left region plus the right region. So that's your little shortcut for your formula. It's going to be integral of the left plus the integral of the right. All right, so the left one is the x, and the right one is going to be cosine of x. And we have our bounds already, so this is going to be equal to the integral, again, between 0 and 0.739. And the left I said was x, then dx, plus now the integral from 0.739, what was it, 1.571, or pi over 2. I'm just going to say 1.571, and cosine of x dx. Type that in on your calculator. I actually thought it was 1.570, or just, yeah, 1.570. So I think it's going to be basically the same answer. 1.599, ooh, that's going to round it up. So it's 0.600. So 0.600. I think if you do 0.55 or 0.599, you'll still get full points. And then for part C, find the volume when revolved. Okay, that means I'm going to have a pi. So my general formula is going to be pi, the integral, it's around a line, not the x-axis. So it's going to be outer minus k quantity squared minus the other radius, which is going to be inner minus k quantity squared. All right, so our actual formula that we're going to be using is the integral. It's r. So r is just that left region. So 0 and 0.739 are bounds. 0.739. And the outer function, so if I'm rotating around this line, the outer function is going to be x. The inner function is going to be, or sorry, the outer function is going to be cosine of x. And then the inner function is going to be x. So I'm going to say cosine of x minus 1, that quantity is going to be squared, minus, and then it's going to be x minus 1, that quantity is going to be squared, and then all of this stuff, we'll do curly brace here, all of that stuff is going to be multiplied by d of x. And
Wait, question?
yes.
So it says revolved around the line y equals 1, not x equals 1. Is that important?
Yeah, so y equals 1 is a horizontal line. Y equals 1, like
okay.
So luckily we're still in good shape. We haven't done any hard.
Yeah, that was what fooled me because it says y. Yeah, got it. All right.
Yeah, so I highly recommend graphing y equals 1, and hopefully we all remember y equals 1 is a horizontal line. So if you're rotating around a horizontal line, you're good. And I haven't typed all this incorrectly. In fact, I think I started typing it wrong because I started doing x instead of cosine. So let me come over here and type over this. This is going to be cosine of x. That's going to be squared minus, and then in parentheses, x minus 1, that quantity is going to be squared. And then that's going to be with respect to x from 0 to 0.739. And what did I mess up on? Probably some parentheses. Yeah, I forgot my parentheses here. So second, delete to insert another parenthesis and then hit enter. 0.914. That's not what I got on my, oh my gosh, I forgot to subtract 1. Okay, cosine of x. Right here, I should have subtracted 1. So second insert to -1. And now if I hit enter, I'll get the correct answer. There's the answer I'm looking for. And uh-oh, you guys see what's going on here? Here, let me second enter.
It's a negative.
It's a negative, which means what?
You
If this is a negative answer, so the answer is supposed to be 0.996, which is the correct answer. But that means what happened over here?
You did the inner minus the outer?
Yeah,
or I don't know.
I should have done outer minus inner, and as you said, Gio, I did inner minus outer. So what happened here? I should have graphed my line. That would have saved me from making an error. My line's up here, which means my outer is actually my x. So I should have started with x and then minus my inner. I thought I was revolving around the x-axis again, but I'm not. So always draw your line of rotation. So let me fix this for my notes. This one, I'm going to be getting rid of. This I'm going to move right there. Move the just want to move the minus sign. Move the minus sign. Move the minus sign. I literally can just redraw this minus sign. What am I doing? Okay, that's the correct formula. and you get 0.996. Cool. So that concludes our self-check 11.6.